Have you ever wondered how apps like Google Meet, Zoom, Discord, or even online multiplayer games let people communicate in real time with almost no delay? Think about it. When you speak during a video call, your voice reaches the other person within milliseconds. No page refreshes, no constant polling, just instant communication. So what's the magic behind it? The answer is WebRTC. In today's video, we're going to explore what WebRTC is, how it works behind the scenes, why it's become the backbone of modern real-time applications, and where it shines and struggles in the real world. Let's dive in. WebRTC stands for Web Real-Time Communication. It's an open-source technology that allows browsers and mobile applications to communicate directly with each other using simple JavaScript APIs. Now, here's the really cool part. Unlike traditional communication systems where everything goes through a server, WebRTC enables peer-to-peer communication. That means two devices can exchange audio, video, and data directly. Imagine you're sending a package to your friend. Traditional communication is like sending it through a warehouse. WebRTC is like delivering it directly to their doorstep. This brings three major benefits: lower latency, better performance, and reduced server costs. And the best part? No plugins required. Modern browsers support WebRTC natively. To understand WebRTC, we need to understand its three core building blocks. Think of them as the three superheroes that make real-time communication possible. Let's start with MediaStream. This API is responsible for capturing audio and video from the user's microphone and camera. When you see a browser pop up asking, "Allow access to your camera and microphone," that's MediaStream in action through the Get User Media API. Without it, there would be nothing to send. Next comes the real MVP, RTCPeerConnection. This is the engine that manages communication between two peers. It handles network connectivity, bandwidth optimization, codec negotiation, security, media transmission. In simple terms, it's the component that actually builds and maintains the connection. What if you don't want to send audio or video? What if you want to send text messages, files, game data, or live cursor positions? That's where RTCDataChannel comes in. It allows fast, low-latency, bidirectional data transfer between peers. This is why WebRTC isn't just for video calls. It's also used for multiplayer games, collaborative applications, file-sharing platforms, real-time dashboards. Now comes the interesting part. How do two strangers on the internet discover each other and establish a direct connection? WebRTC follows a series of steps. Let's walk through the journey. Before two peers can communicate, they need to introduce themselves. This process is called signaling. Interestingly, WebRTC doesn't define how signaling should happen. Developers can use WebSockets, Socket.io, SIP, custom APIs, anything that can exchange messages between users. Think of signaling as exchanging phone numbers before making a call. Once signaling is established, the first peer sends something called an SDP offer. SDP stands for Session Description Protocol. The offer contains information such as supported codecs, media capabilities, network details. The second peer reviews it and responds with an SDP answer. It's basically a negotiation process. Peer A says, "Here's what I support." Peer B replies, "Great, here's what I support too." And together, they agree on a common setup. Here's where things get tricky. Most devices on the internet are hidden behind routers and firewalls. This is called NAT, or Network Address Translation. Because of NAT, devices often don't know how to reach each other directly. So WebRTC uses a framework called ICE. ICE stands for Interactive Connectivity Establishment, and ICE relies on two important helpers. A stun server tells your device, "Hey, this is your public IP address." Think of it like looking into a mirror and discovering how the outside world sees you. Sometimes firewalls are extremely strict. A direct connection simply isn't possible. In those cases, WebRTC falls back to a turn server. Instead of communicating directly, traffic is relayed through the turn server. This guarantees connectivity, but it comes at a cost because now the server has to carry all the media traffic. Let's put everything together. Here's what happens when you start a video call. Step 1. The browser requests access to your camera and microphone. Step 2. The application exchanges SDP offers and answers through a signaling server. Step 3. ICE gathers network candidates using stun and turn servers. Step 4. A secure DTLS handshake establishes an encrypted connection. Step 5. Audio, video, and data start flowing directly between peers. And all of this usually happens in just a few seconds. Pretty impressive, right? No technology is perfect. Let's talk about where WebRTC excels and where it faces challenges. Advantages. Built into browsers. No plugins, no downloads. Just open the browser and start communicating. Ultra-low latency. Because communication is peer-to-peer, delays are incredibly small. Strong security. Encryption isn't optional. WebRTC mandates secure communication using DTLS and SRTP. Reduced infrastructure costs. Less media traffic passing through servers means lower hosting expenses. Challenges. Browser differences. Although support is widespread, browser inconsistencies still exist. Developers often use Adapter.js to smooth out differences. Battery and CPU usage. Real-time audio and video processing can be demanding, especially on mobile devices. IP exposure. Certain configurations can reveal network information, creating privacy concerns. Turn server costs. When peer-to-peer communication fails, relay servers can become expensive at scale. You probably use WebRTC every day without realizing it. Here are some common applications. Video conferencing. Platforms like Google Meet, Zoom Web, and Discord rely heavily on WebRTC for real-time communication. Cloud gaming. Services use WebRTC to stream gameplay with minimal latency. IoT and robotics. From drone video feeds to baby monitors, WebRTC enables instant communication between devices. Real-time collaboration. Whiteboards, file-sharing tools, and collaborative editors can all benefit from WebRTC's low-latency data channels. So, what have we learned today? WebRTC is the technology that powers real-time communication on the modern web. It enables browsers and apps to exchange audio, video, and data directly with minimal latency. Behind the scenes, technologies like signaling, SDP, ICE, stun, turn, DTLS all work together to make seamless communication possible. And as technologies like QUIC, AI-powered noise cancellation, and 5G continue to evolve, the future of WebRTC looks even more exciting. If you've ever built a chat application, video conferencing platform, multiplayer game, or collaborative tool, WebRTC is definitely a technology worth mastering. If you found this video helpful, give it a like, subscribe to the channel, and let me know in the comments, what's the most interesting real-time application you've seen built with WebRTC? Thanks for watching, and I'll see you in the next one.